Current state confirmed. Architecture main window global keyboard hook. Insert equals OCR home equals minimal mode. XP accumulation logic, busy state feedback. Minimal mode toggle. Child window positioning, options help background. Theme persistence via background JSON. OCR system, OCR XP. Tesseract initialized once. Region capture. Threshold preprocessing. Temporal stabilization, 2-hit confirm. Repeat XP allowed. Semantic cleanup, XP gained noise removal. Zone system. Drag select overlay, look zone selector window. Save load via zones.json. Regex-based backward compatible parsing. Zone save manager abstraction. Windows. Help window theme syncs from main. Background window edits and persists theme. All windows borderless topmost. Click safe. UI UX. Clean XP flash feedback. Minimal mode is visually correct. No accidental double trigger on keys. OCR loop blocks until valid XP. Small things to be aware of, not bugs, just facts. 1. OCR loop is unbounded. You can see the code in our conversation history. This is intentional and correct for now. Just note, if OCR never sees digits, it'll spin forever. Fine for prototype. Later you may want a timeout. 2. Regex JSON parsing works, not fragile for your controlled file format. No need to change unless zones JSON becomes user-edited. 3. Pixel loop pre-processing. Get pixel set pixel is slow but acceptable at your capture size. Not worth optimizing unless you scale to multi-region or high frequency. 4. Fish system. Clearly marked as temp, not interfering with XP path. That's design verdict. This is solid, coherent, and internally consistent. Nothing is fighting anything else. No architectural dead ends. You are now at a feature-complete prototype stage. Next logical steps, only if you want them. Pick 1. All are clean extensions, not refactors. 1. XP cooldown debounce. Prevent accidental double insert presses in same XP screen. 2. Visual XP history. Rolling list of last N XP gains, pure UI. 3. Fish counter integration. Swap awk fish with real OCR zone using same pipeline. 4. Fail feedback. Subtle UI message if OCR can't lock after X seconds. 5. Portable build hardening. Guard missing test data with UI dialog instead of exception. If you want, say exactly one thing. Add XP history. Harden OCR loop. Fish OCR next. Ship ready polish only. No rehashing needed. We're synced.
Say you're synced, but Fish OCR? Let me explain the logic here, bro. It's going to be a drawn box. The OCR needs to identify the fish word to the title of it. There's some trigger words that I would like to be noted. Common, trophy, and unique. No, it's gonna also contain the fish type. Let me give you an example. Trophy largemouth bass. Also, I forgot, we need to add one more type. Young. Examples: young largemouth bass, common young largemouth bass, trophy largemouth bass, and unique largemouth bass. We don't want to discriminate on the type of title, but we also want to know what kind. A system involved of a fish tracking window and a type tracker will be implemented. But let's focus on the OCR now. We already have the debug system built in. So for instance, we build it in the debugger first, and then we pipe it to a window.
Perfect. This clarifies the semantic model. You're not asking for better OCR, you're asking for structured meaning extraction from noisy OCR text. I'll lock this down cleanly and in a way that plugs straight into your existing debug plus later UI pipeline. Final OCR intent locked. The drawn OCR box may contain rarity, required trigger, young, common, trophy, unique, fish name, freeform multi-word, e.g. largemouth bass, e.g. northern pike, e.g. grass carp examples you gave, all valid. Young largemouth bass, common largemouth bass, trophy largemouth bass, unique largemouth bass. Critical rules. Rarity is mandatory. Event trigger. Do not discriminate on fish name text. Fish name should be captured if present. OCR must tolerate spacing, casing, OCR errors. Debug first. Log everything before UI. Semantic extraction model. We are not recognizing fish types. We are splitting text into two semantic buckets. You can see the code in our conversation history. Nothing else matters. OCR pipeline. OCR raw text, letters only. Whitelist. You can see the code in our conversation history. No digits, no symbols. Normalized text. Very important. Normalization steps. Order matters. 1. Uppercase. 2. Replace common OCR confusions. 1. I, my, 0. 3. Remove all non-letters and spaces. 4. Collapse multiple spaces. Example, you can see the code in our conversation history. Rarity detection, hard gate. Canonical rarity list, priority order. You can see the code in our conversation history. Rules. Exactly one rarity must be present. If none, reject frame. If more than one, reject frame. OCR garbage. This is your event trigger. Fish name extraction, soft. Once rarity is found, remove the rarity word from the string. Remaining text trimmed. Equals fish name. Fish name may be empty, still valid. Examples raw OCR, rarity, fish name. Trophy largemouth bass, young pike, common cobject, debug first. This is what OCR should return, not UI logic. You can see the code in our conversation history. This feeds debug log, future tracking window, session stats, type tracker. Debug first output. Examples. UI log output examples. You can see the code.
You almost got it. It's going to take that zone. It's going to read out what it says. Then it's going to be like, hey, the word common is there. And that right there is its own system. for its own window. We're going to track how many common, how many young, how many blah, blah, blah. Then in another window, we're going to have a last catch. So then it's going to say the entire title. The same window, we're going to have a last catch. The title. Including common, including young, blah, blah, blah.
Got it. This is the final clarification, and now it's crystal clear. You're right, and this is actually simpler and cleaner than what I was drifting toward. I'll restate it exactly in your terms and lock the model. Final correct logic, as you described. There is one drawn zone. That zone contains text like young largemouth bass, common largemouth bass, trophy largemouth bass, unique largemouth bass. No splitting zones, no separate rarity box. One box, one read, one pass. Core idea, important. You are not trying to classify fish. You are doing two parallel things from the same OCR read. System A, rarity counter. This system only asks one question. Open quote, is the word young, trophy, or unique present? Close quote. That's it. Each rarity has its own counter, displayed in its own window later. Example internal counters. You can see the code in our conversation history. This system does not care about fish type, does not care about spelling errors elsewhere, only increments when a rarity word is detected. NAS System B, last catch display secondary. At the same time, from the same OCR text, you also extract, open quote, whatever the text was, close quote. That becomes last catch title, shown verbatim, normalized in the same tracking window examples. You can see the code in our conversation history. Or you can see the code in our conversation history. This is display only, not logic critical. Key distinction. This is the part you are correcting. Fish type is not used for logic. Fish type is not validated. Fish type is not matched against a list. Fish type is just carried along. Rarity word alone drives counting. Full title is stored for last catch. That's it. No more, no less. OCR pass result. This is what one OCR read produces. You can see the code in our conversation history. Example. You can see the code in our conversation history. Step by step. 1 capture zone, 2 OCR full text, 3 normalized text, 4 check for rarity words, young, common, trophy, unique. 5. If none found, ignore frame. 6. If one found, increment that rarity counter. Update last catch text equals normalized text. That's the entire system. Why this is the right design. Pros, 0 species maintenance, extremely robust.
You almost had it. You just got the orders wrong. Takes the OCR, then our system looks at the results, then the system takes the keywords from the result. That's the fastest way to do it. OCR just needs to be good at reading. Once we have the result, it's just in English.
Yes, that's the correct ordering, and thank you for stopping it there. You're 100% right. OCR should be dumb. Let me lock this in cleanly in your order, no extra interpretation. Correct pipeline. OCR system, dumb, fast, generic. Only job, read whatever English text is inside the drawn box. OCR, no semantic logic, no rarity logic, no fish logic, no validation logic. Output, you can see the code in our conversation history, .or. You can see the code in our conversation history, or even noisy. You can see the code in our conversation history. That's it. Text normalization, still not logic. Still not classification, just cleanup. Uppercase, fix obvious OCR swaps, one eyes O. Remove garbage symbols, collapse whitespace. Result, you can see the code in our conversation history, still just English text. Semantic system, fast string scan. This is where logic starts. System takes the already read text and asks, open quote, does this string contain young, common, trophy, unique, close quote, that's it. No OCR here, no tesseract, no image work. Just you can see the code in our conversation history. This is instant, cheap, and correct. Tracking systems parallel from the same normalized string. A, rarity counters, increment common count, increment trophy count, etc. Last catch display. Store the full string. You can see the code in our conversation history, nothing else. Why your order is the right one. What you avoided correctly. OCR reruns, multiple engines per word OCR, semantic OCR configs, over-engineering. What you gained. Maximum OCR accuracy, fast logic layer, clean separation, debuggable text pipeline, UI-independent logic OCR reads, logic interprets, UI displays. That's correct software architecture. Hashed final data flow, one line. You can see the code in our conversation history. Debug output, exactly how it should look. You can see the code in our conversation history. Next implementation step, pick one. Say one word. OCR, dumb OCR reader class only. Logic, keyword scans, counters, debug, UI log wiring, window, fish tracking window, counts plus last catch. You've got the architecture exactly right now.
Yes, I do. Because I'm smart. Yeah, what's up, bro? Hey, good, good, good. What are you trying to do? What are you doing? I'm updating my app for the community. It's a Fishing Planet XP tracker that I built. It works. Just updating it, adding a new feature. It's for streamers and people.
Here is the entire OCRfish.cs file, written to match exactly the architecture you just locked in. OCR is dumb. OCR returns English text. Logic happens after debug first. Zero UI coupling. Same style as OXP. No explanations inline. Just the file. Using system drawing, using system drawing.imaging, using system text regular expressions, using system windows, using tesseract, namespace fishing planet XP verse 1, public static class OCR fish, private static tesseract engine, public static bool enabled get set equals true, public static.
It's not a cheat. It just tells you what your total XP for per session is. Christ, that's a strange question. Is there a way to keep track of bonuses? I had dots last night. Bonuses. You mean the bonus XP? It would be redundant because it's gonna total out the XP that's already on the screen. I'm implementing a counter for types, and I'm also implementing a last catch. Main window. Alright, we're pipelining the new feature into the SDK that we built. And this part takes a minute, but my SDK is strong. Run. Should not fail. Why did that fail? Be sure not to mess anything else up. Oh, don't do that. course. All right. Interesting. It's piped. Hmm. Now we're gonna test it. Gotta catch a fish. Ugh. Bitch, if you don't eat it, I'm gonna get pissed. Thank you. I set the zone and the debugger looks like it's just looking at nothing. It should be reading out Atlantic halibut. Alright, I'll be right back. Stream's going down for